Watch this. Clone. Open the code. Run. Browse. And your entire .NET system is running. API, Postgres, Redis, everything. Let's hit an endpoint. Success. This is .NET Aspire, the development stack that handles your infrastructure setup so you can clone and start building from day one. By the end of this video, you will know how to transform a basic .NET API into something ready to deploy to production. Let's start. So what is .NET Aspire? It is a set of tools, templates, and packages for building observable, production-ready, distributed applications. .NET Aspire enables a simplified developer experience by booting your entire .NET system, not just one app, after cloning your repo and hitting F5. It includes dozens of pre-built building blocks for popular services that seamlessly connect to your app with smart defaults and no extra configuration. Aspire lets you define your entire infrastructure in C#, making environments predictable and easy to reproduce from dev and all the way to production. Plus, it includes a real-time dashboard to monitor and troubleshoot your application before slow dependencies and service failures impact real users in prod. We said that .NET Aspire helps you build production-ready applications. But what does that mean? Well, here we have an ASP.NET Core application which uses a lightweight SQLite database. The application runs great in our deadbox, but it is not quite ready for production since it's missing a few key elements. A scalable database like PostgreSQL, which is ready to handle the increasing load as our application scales. A caching service like Redis to improve response times and reduce database load as user traffic grows. Resiliency with smart retry policies to handle inevitable service failures gracefully. Health checks so that the application can self-heal when unexpected issues impact the app or its dependencies. And observability, which translates into having enough logs, traces, and metrics to troubleshoot the application effectively. Before we start, you need to know Docker. We'll be using it across this video, so if you're not comfortable with the basics yet, watch my free full course for .NET developers first. You'll find the link in the description. To follow along, make sure you have this installed: the latest .NET SDK, Docker Desktop, and Visual Studio Code or your favorite code editor. Our starter application is a small ASP.NET Core API that exposes a few basic endpoints to manage a catalog of video games. Now I have the application running already, so let me show you how it works. I'll collapse this and this for a moment. And we can start by querying the games endpoint, which is going to go ahead and retrieve the full list of video games. As you can see right here, we have 4 games right now stored in there. We can also use this second endpoint to retrieve just one of the games. Let's say game 1. I'll hit send request, and now we have our one game over there. And we can also use this other endpoint to create a brand new game in the database. So I'm going to click on send request. We can see on the right side, the game has been created. It got ID 5. And we can now query the full list of games again to see that our brand new game is listed at the very end. There are a couple of other endpoints to perform updates, like with this put endpoint here to update a game. And we also have this delete endpoint to delete a game, but I think you get the idea. Now, one thing to notice is that if you go back to the Explorer view, is that this API is using an SQLite database, as you can see right here. It is a small SQLite database that makes it very easy to get started with ASP.NET Core and Entity Framework Core. And you can also see the configuration for the connection string here in appseries.json. You can see that we are connecting to that database by just pointing to the GameStore.db file. If you want to go over the steps to create this application, please check out my ASP.NET Core full course video where I cover the full implementation from start to finish. Now, in this video, we will focus on getting this application ready for production. And the first step towards that is going to be to switch to a scalable database like PostgreSQL. Now, how do we move this application from SQLite to PostgreSQL? Well, normally the first thing that you have to do is figure out a way to run PostgreSQL in your box. One way would be to actually install PostgreSQL in the box, but ideally you don't want to do that, and instead you want to just run a Docker container. And for that, what you would do is go to Docker Hub, which has every single public image available, and perhaps we can start by searching for PostgreSQL, right? So I'll hit enter, and then I have a few options here like Bitnami PostgreSQL, ManageIQ PostgreSQL, VMware PostgreSQL. Well, none of these actually look like the one that I want, and perhaps I didn't even type this properly. So let's see, perhaps what I want to do here is Postgres. Let me do a broad search here. And this brings up other options, including the official image for PostgreSQL that I can see here, which is likely what I want to use, but still I see many other options, right? So MCP Postgres, we have CMAG Postgres, CircleCI Postgres, LSTO Postgres. There's so many options just for Postgres, right? So small challenge to find out what is the right image to use, but let's say that we want to go for this first one, Postgres, right? So let's click on that one. And then the second thing that we have to figure out is, well, how do we actually run this image? So let's see, this is Postgres, and let's see, I can see the tags over here. Let's scroll down here, scroll down. At some point, we should be able to find the actual run command. So yeah, here it is. So we can see here's the command to do the Docker run with the name. We want to pass a environment variable for the password, as we can see here, and then the actual name of the image, right? It says nothing really about the user, how to specify the user, but it says a password over there. Now, if we keep going down, we're going to find there's also a way to do this via Docker Compose, as we can see here, if you want to use that. And then we're going to find, well, descriptions of a bunch of other environment variables, including the Postgres user that's over here, and many other environment variables that we could use with this image. But still a little bit of a challenge to figure out exactly the right way to run this Docker container. Now, once we have figured out that this is the container that we want to run, the next thing that we may want to know is, well, how do I connect to it from my .NET application? And for that, after searching a little bit, you may eventually land in the connectionstrings.com page, which is a common page to figure out connection strings for different software or databases. So in this page, I'm just going to look for Postgres. So here we have PostgreSQL on the left side. Let's go over there. And here we're going to find a few ways to connect to it, right? So if you want to use .connect, says here, here's the standard way to connect to PostgreSQL. Here we have PostgreSQL OLADB provider, another way. Then we have the .NET framework with OLADB. Then we have ODBC, ANSI, Unicode. Then we have MPG-SQL, which is the one that I'm more familiar with. But there's many ways, right? Many ways to connect just to PostgreSQL. Which way to use? We don't know yet. I think this is going to be the way, but we'll see. And then when we have figured out the right connection string, we still have to figure out what is going to be the correct NuGet package to connect to PostgreSQL. And after searching a little bit, you're eventually going to land into this MPG-SQL page over here, which is the official .NET package for PostgreSQL. So if you go into MPG-SQL, this is going to give you some directions on how to connect to PostgreSQL by using, in this case, it's going to be just ado.net. Right? But we are using Entity Framework Core, so we likely want to switch to Entity Framework Core over here, and this is going to give us instructions on how to connect to PostgreSQL and all of those details. So running PostgreSQL and connecting to it from our application is not that hard, but still I'm going to spend 10 to 15 minutes just trying to figure out what is the right way to connect. And likely I'm going to make mistakes at the start. I'll have to do things over again. So instead of doing all of this, let's see how we can use .NET Aspire to integrate PostgreSQL into our application in a much more streamlined way. So let's go back into Visual Studio Code, and the first thing that we're going to need is the .NET Aspire project templates, which we can install via the .NET CLI. So let's go ahead and open our terminal here. I'm going to stop my server. Perhaps I'll make up more space here, and I'll expand this. Clean this. I'll just go over one directory, and let's just type .NET new install aspire.project templates. Hit enter. Let me zoom out a little bit. And as you can see, this is the full set of project templates that allow you to create either a brand new Aspire application by using, for instance, the Aspire template or the Aspire Start template, or you can add specific projects to your existing .NET application that are going to enable the Aspire experience, like is the case of Aspire AppHost and Aspire Service Defaults. And as you can see, there are also projects for unit testing, as you can see here, here, and here. Now, to make sure that our development environment, VS Code in this case, recognizes these brand new templates, what we're going to do is either close and reopen VS Code or just reload the window, which is what I'm going to do right now. So I'll do Ctrl-Shift-P and I'll do developer reload window. All right. So now all of these templates are available and are going to show up when I do .NET new list that is going to present the brand new set of Aspire templates at the very start over here. But before we use any template to start creating our first project, there's one more thing that you may want to install, which is the Aspire CLI, which is a very nice way to work with your Aspire projects during local development. Now, let me clean this. And to install the Aspire CLI, all you have to do is .NET tool install. Let's make it a global tool with -G and then aspire.cli. You don't have to use the Aspire CLI, but it is a great option when you're working with Aspire projects in your local box. Now, we could use the .NET CLI to create our Aspire projects. But in the case of VS Code, you can also do this by using the Solution Explorer. So let me zoom in once again my terminal and let me just close it for now. Let's open up our Explorer view and we can switch now into the Solution Explorer. Now, if you don't see the Solution Explorer over here, what you may be missing is the C# dev kit. And to install it, what you can do is, let me show my activity bar for a moment. You can just go into your extensions view and you just have to look for C# dev kit, which I already installed, this one over here. And this is going to enable the Solution Explorer and many other .NET specific experiences for your VS Code environment. Okay, so let's go back to Explorer view and let me just remove the activity bar for a moment so we can have more space. And let's go ahead and create our first Aspire project, which is going to be our AppHost. Let's right click, in this case, in Game Store, new project. Let's select .NET Aspire AppHost. Let's give it a meaningful name. It's going to be GameStore.apphost in this case. Let's choose a default directory. And then here you're going to have a few options that are useful in the case, for instance, if your project targets .NET 8 and not .NET 9, you could use this option here to switch to .NET 8. .NET Aspire will work with .NET 8 at the time that I'm recording this, but just keep in mind the Aspire CLI does need the .NET 9 SDK installed or it will not work. Here you can also see the version of .NET Aspire that I'm using right now, 9.4. Now let's click on Create Project. Project is created. And now I'm going to switch back into my File Explorer. Here is our AppHost project. Now, the main purpose of this AppHost project is to become the new host of your .NET application that is going to host not just your API project in this case, but also any external dependencies like the PostgreSQL database container that we're going to be using across this project. So in that sense, it is an orchestrator for the different components of your application. And if you're curious, if you take a quick look at your project file, you're going to notice that this is nothing more than a console application. As you can see right here, it is a console application. And all it has is a couple of extra references to a special SDK, as you can see here, and a particular NuGet package over there that both enable additional behaviors specific to .NET Aspire and also a bunch of different types that we're going to be using across our Aspire application. Now let's close this. And let's go into this file here. This is the only C# file you're going to find here, apphost.cs. And this file here is going to become the entry point to your Aspire application. And it's also the place where we're going to define what we know as the application model. The application model is the place where you define all of the components of your system. Like I said, not just the API project, but every single external dependency needed by your applications. I'll explain more about the AppHost and the application model later in the video. But for now, let's see how to use this to integrate a PostgreSQL Docker container into our application. And for that, what we can do is install what .NET Aspire calls a hosting integration, which is a NuGet package that knows how to provision this container for us. Now, to know exactly which NuGet package to install, what you can do is go into the .NET Aspire documentation page And you can go straight into the .NET Aspire integration section over here. Click on that. And what you're going to see on the left side is a big list of all of the available integrations right now, which is a growing list. And from these ones, we can either pick the PostgreSQL integration on the left side, or in our case, since we do want to integrate with Entity Framework Core, we can pick the node over here, Entity Framework Core, expand that, and then here we should be able to find a section for PostgreSQL. Now, there are two types of integrations. There's a hosting integration and a client integration, but right now let's focus on the hosting integration. So if we scroll down a little bit, we are going to find what is that NuGet package that we need to use for PostgreSQL. So let's just copy that. Let's get back into VS Code. So open our terminal. Let's expand this. Let me switch into my Game Store AppHost project. And let's go ahead and install the Aspire Hosting PostgreSQL integration. Great. Now let's close this. And let's go back into apphost.cs so that we can start modeling the application. And like I said, the first thing to introduce is PostgreSQL. So what we're going to do is the following. We're going to say builder.add Postgres. And here you have to specify a name for this resource, a unique name. Let's just name it Postgres. Just by adding this one line, we are telling .NET Aspire that we have an application model that must include a PostgreSQL resource. In this case, in the form of a Docker container. Now let's run our Aspire application to see what is going to be the effect of adding Postgres into our model like this. To run your application, you can either do just a simple F5 and select the AppHost as your starter project, or you can use the Aspire CLI. I'll be using the Aspire CLI for this video. So let's open up our terminal once again. I'm going to clean this. Perhaps I'm going to expand this a bit. And I'll just do Aspire run. Now, if this is the very first time that you run your Aspire application, you may be asked to install the self-signed certificate for localhost, because Aspire by default is going to try to use HTTPS for hosting your application locally. So I'm going to say yes. And as you can see, the application has started. And it is even giving us this URL to browse to what is known as the Aspire dashboard. Now, before we go to the dashboard, one thing that you may want to notice here is that our Postgres Docker container is already running. And you can confirm that by going into your Docker desktop installation. So let me open Docker desktop now. Here it is. And as you can see, my Postgres Docker container is up and running right here. In this case, it is using the Postgres 17.5 version. And we can also see that the corresponding Postgres Docker image has been downloaded over here. So this is one of the key benefits of .NET Aspire, because I did not have to figure out where to get the Docker image or how to run the Docker container or what version even to use, right? It just worked without us having to do anything more than adding that one line. Now going back to VS Code, let's click on this dashboard link over here, which is going to take us to the .NET Aspire dashboard. This dashboard is included with the AppHost project, and it is designed to enhance the development experience by providing a clear and insightful view of your application state and the structure. Now, as you can see, we do have one element right now, one resource in our application, which is our Postgres database. And like I said, it has already decided which Docker image to use for Postgres. So you can see here is Postgres 17.5. It assigned an address for Postgres, as you can see over here. So I didn't have to think about what port to expose locally to reach to my Postgres Docker container. And if we click on it, this is going to expand on the right side, this pane with much more information about this container. And that is going to include, as you can see here, the connection string that you can use to connect to it. If we click here and we click on show value, we will be able to see the full connection string that you can use to connect to the application. So we no longer have to go into a website to try to figure out what is the right way to connect to Postgres from my .NET application. The connection string is right here. It is dynamically built by .NET Aspire, given what it knows about your application model. If you keep going down, you're going to see many other things about this resource, but it also includes a few things like the environment variables that have been set to configure it, right? And that is going to include the Postgres password over here. Here's the password that was automatically assigned by .NET Aspire to this container instance, and also the user that you can use to connect to it if you wanted to. So as you can see, a bunch of smart defaults so that you don't have to think about those and just focus on building your application, right? Not on these infrastructure deals. Now let's close this. And one thing to keep in mind is that these defaults are configurable, right? So you get the defaults to get started fast, but you can also customize many things about these resources in your application model. For instance, one thing that I may not like is the port that was assigned to PostgreSQL. What if I want to connect to this instance from my favorite tool for PostgreSQL? I don't want to be dealing with random ports all the time. So in that case, what you can do is going back to VS Code. Let's just Control-C to stop the hosting process for a moment. Let's close this. You can start customizing how this resource is added to your application model. So if I want to use a different port, what I can do is just say dot with host port. And let's say I want to go with port 5432. That will make it so that .NET Aspire assigns that port to the container. And just like that, you could also go ahead and say, hey, I want to use a different image. So you want to say with image, and that allows you to specify a different container image for your Postgres database. Or if you want a specific image tag, you can also say with image tag, right? So you can pick your specific version of PostgreSQL that you want to use. Now in this case, let's say I just want to change the port. So I'll just go for with host port 5432, and then I'll rerun my application. Aspire run. Now I'll go back to my dashboard over here, just refresh. And as you can see, the port has immediately changed. So very easy to specify how you want to configure this resource. Now, of course, it is not enough to just have Postgres in there. We also need to have a specific database for our application. So let's go back to our VS Code instance. I'm going to stop my server again. And what I'm going to do now is to add a database as a child resource of this Postgres resource. I'll start by assigning this Postgres resource into a specific variable. So I'll do var Postgres equals builder.addPostgres, and I'll be using that variable later on. But for now, what I can do is say Postgres.addDatabase. And for this database, I want to pick a name that matches exactly the name of the connection string that my application is already expecting. And we're going to see why this is important later, but let's start by taking a quick look at that connection string once again. GameStore.api, let's go into AppSettings.json. Over here, remember that we have connection strings here, and our connection string is named GameStore right now. So let's go ahead and just copy that specific key as it is, copy, close this, and let's paste that over here. This is going to signal .NET Aspire that it needs to add a child resource of the Postgres resource with a name of GameStore. Okay, so if I rerun my application now, Aspire run, and I go back to my dashboard, over here, we're going to see that our database has been created. And as you can see, it is a child resource of the Postgres resource over there. Great. But now, of course, what we may want to do is to explore a little bit this Postgres instance to confirm that, well, the database actually exists over there, even if it doesn't have any tables just yet. Now, one way that you can do this is by using your existing IDE or whatever tool you use today to talk to Postgres. And that would work if you just use the connection string that we saw a moment ago. But another way to do this is by spinning up a new container for the tool that we need as another resource in our model. Let me show you how to do that. Let's go back to VS Code. Let's stop this, close. And what we can do is let's go back into our Postgres resource declaration. What we can do now is chain another call to another method called with pgadmin, which in its simple form is going to go ahead and add a pgadmin for Docker container to our application model and already connect it to our Postgres resource, which is great. But one more thing that I like to do with this resource here is to also customize what is going to be the port where I'm going to run it, because I like to just keep it open in one tab in my browser and just go back to it without having to change ports. What I can do is add a Lambda expression here. Let's say pgadmin, and here I can customize this associated resource, right? So we can say pgadmin dot with host port, and let's say I want to go for port 5050. And since I'll be accessing or exploring this PostgreSQL instance directly with this tool, I will not really need to use a very specific port for PostgreSQL instance itself. So I'm going to go ahead and just remove this and let the Aspire figure out the port. So with that, let's go ahead and rerun our Aspire host. Let's go back to the admin dashboard over here. And as you can see, a new resource is spinning up over here, right there for pgadmin. This one usually takes a little bit to the very first time. So let's just give it a few seconds. And now that it went into running state, what I can do is just click on the URL that has been assigned to pgadmin with the port 5050 as we requested. Let's click on it. And as you can see, we are not only already in the pgadmin user experience here, but we are also already connected to our Postgres database. You can see the database is right here. We didn't have to connect it explicitly to pgadmin. It is just right there. And if we expand the databases, we're going to see that our game store database is also right there. It will have nothing right now, but it is ready for us to start working with it. Now, there is one more thing that it's important to add to our application model. So let's go back to VS Code. Let's stop our Aspire AppHost. And one thing that I want to show you going back to Docker Desktop is that our container is actually going to disappear as we stop our Aspire application, meaning that these containers are ephemeral, right? So if you're dealing with a database as we are doing right now, you probably want to make sure that that data is persisted across your Aspire sessions. So for that, what you want to do is to use a data volume, a very common thing with containers. And to enable a data volume with .NET Aspire, all you have to do is just make one more call over here. I'm going to do it just before that with pgadmin. I'll say dot with data volume like that. And that's going to make sure that a data volume is attached to this instance. All the data that our application creates is going to be persisted there. So if we start once again our Aspire application, back in the dashboard, let me go back to the dashboard over here. We're going to see that now if we click on Postgres on the right side, we should be able to see that a volume is now configured for this container, right? And it is already configured for the correct path where you are supposed to map your localhost path so that all the data inside the container is mapped outside of it, right? So we didn't have to investigate or configure this path manually as you would have to do with Docker Compose. The path is automatically figured out by the hosting integration for PostgreSQL, which is a great benefit of the .NET Aspire. Now, before we bring in our actual API ASP.NET Core application into our application model, let's understand a little bit better what is the AppHost and the application model. In the .NET Aspire, the application model is the blueprint that defines all the building blocks of your system as a collection of resources. We just introduced our first resource, a PostgreSQL resource, into our application model, and we did it by installing the PostgreSQL hosting integration, a NuGet package designed to provision PostgreSQL as a container. Resources can also exist in parent-child relationships, as is the case of our database resource, a child of the PostgreSQL resource. This allows the parent to control the lifecycle of child resources and enables nice dashboard visualizations. As you saw, this application model is defined in the AppHost, a .NET Console application that orchestrates the application resources when you run the app either by the CLI or by hitting F5. The AppHost won't perform this orchestration directly, but instead will delegate it to the Developer Control Plane, or DCP. The DCP performs many tasks to honor the desired view of the resources expressed in the application model. Since our application model declares a PostgreSQL resource, DCP will start a PostgreSQL container, not by itself, but by delegating this task to a container runtime like Docker. The DCP will then monitor this and any other resource to provide both resource change notifications and log streaming back to the AppHost. Finally, the DCP will launch the dashboard, which presents a user-friendly interface for inspecting resource states, viewing logs, and executing commands. You can also add .NET projects as resources to the application model, like our Game Store API. This opens the door to establish dependency relationships between resources, like how our API project depends on the PostgreSQL database. Such relationships add additional information that the DCP can use when starting the resources. So now, when you run your AppHost and the updated app model is sent to the DCP, it will start both the PostgreSQL container and the API project. But more importantly, it will inject the database connection string as an environment variable into the API process, which it can then use to connect to PostgreSQL. In addition, you can enrich your .NET project with client integrations like the PostgreSQL NuGet package here, which already understands how this extra information flows from the AppHost to the project, greatly simplifying your code and adding other key benefits we'll cover later. Before we add our API project to our application model, let's update the database provider that it is using so that it understands how to start talking to PostgreSQL. So if we go now into our API project, into our Store API CS.proc file, let's collapse this, we're going to remember that currently we are using the SQLite database provider for Entity Framework Core. We will no longer be using this, so let's go ahead and remove that line 14 in my case. What we want to do now is to not just add the NuGet package for MPG-SQL, which is a traditional one for PostgreSQL, but we can instead use the .NET Aspire client integration for PostgreSQL, which we are going to be able to find in that same documentation page that we were looking a moment ago. What we can do is just go into the client integration section over here. And this integration is not going to be anything more than another NuGet package that in this case, it is wrapping the native NuGet package for MPG-SQL, but it also adds this understanding of what is coming from the AppHost in terms of environment variables, and also adds a bunch of resiliency, health checks, and instrumentation that we're going to be talking more about later. Now, at this point, we can see the command to install the client integration right there. So let's click on copy. Let's go back to VS Code. Let's open our terminal. And in this case, I'm going to go into my Game Store API project. So this is not AppHost. This is the API project. So I'll paste my command here, hit enter, right? Collapse this. And as we can see, the NuGet package has been installed right here. Now, how do we use this? Well, let's go back to our file explorer. Let's collapse this. Let's go to our program.cs file in the API project. And really all we have to do is to change these two lines where we were registering SQLite before with one more line to register MPG-SQL. So I'll do this. I'll say builder.add MPG-SQL DB context. We will give it the type of our database context, which is Game Store context. And then we will provide the name of the connection string that we need to use to connect to the database. That name is going to be the same name that we've been using so far, Game Store. So let's just copy that name and paste it over here. And as you can see, we no longer need this extra variable to just capture the connection string. We can remove this line 6 and stick with this. Now, how is this going to work? Well, what's going to happen is if we go back briefly into AppHost, apphost.cs for a moment, remember that when we added the database, we added it with a specific name of Game Store. That name is going to be used to be sent as an environment variable all the way into our API project. And the API project is going to be able to read that environment variable via the client integration, and it will get the connection string that it has been crafted by .NET Aspire AppHost if we have the correct name over here. If the name Game Store here matches the name that we are using over here, Game Store, it will be able to retrieve that connection string and use it to connect to the database. And because of this, we can now go also into our appservice.json file in the API project, and we can completely get rid of this connection strings section over here. Get rid of that because the connection string is always going to be dynamic from here on. Now, the next thing that we have to do here is, of course, generate a brand new database migration so that the tables can be created when we start the application. So let's go into our file explorer. And at this point, what I'm going to do is just delete our data migration directory that has been created for SQLite currently. I'll just right click this. I'll say delete. And in fact, I'm going to also delete our SQLite database, which we're not going to be using anymore. I'll just delete the database. It's gone. And now we need to go into our command line to create the migration. So let's open our command line. I'm going to expand this now. I'm going to clean it. And I'll just do .NET EF migrations, add, initial create, and the output is going to be the same location we had before. It's going to be just data migrations. Great. So the migration got created, and we can inspect it briefly by going now into our new data migrations directory. The migration is going to be right here at initial create, which in this case is now ready for PostgreSQL, as we can confirm over here. So now let's go ahead and just close all of this. And let's go back into our file explorer to go back to the AppHost, where we're going to go ahead and introduce the project into the application model. But before we can do that, we have to make sure to reference the API project from the AppHost project so that the AppHost can get access to our project. So let's open up our Solution Explorer. Let's right-click AppHost, add project reference, KStore API. Great. So now going back to our AppHost, what we can do is the following. We can say builder.add project, and here we should be able to find KStore API, which is a type that got automatically generated by .NET Aspire so that we can get access to the project where we have declared our API. And just like with any other resource, we have to provide a unique identifier for this project. So let's just name it KStore API. Now that will be enough for the AppHost to start the API project along with our PostgreSQL resources. However, one more thing that we likely want to do here is to make sure to establish this dependency between the database and the API project so that the API can receive the information it needs to connect to the database. So let's scroll down a little bit and let's do the following. Let's capture a variable for the database. So our database is equals that. And now we can chain one more call after add project. We can say dot with reference database. Great. Now let's run our AppHost and let's see how this reflects in the dashboard, and we'll see if the API can actually start now with information sent over by AppHost. So let's open up our terminal here. I'll just go up one directory and I'll do aspire run. Let's go back to our dashboard right there. And as we can see, the API project is now right here. It is in running state, which is great. It means that it did not have any issues starting. And remember that the application will execute migrations on start. So this is a great signal. And what we can do now is, to start with, let's take a quick look at the environment variables that were sent over to our API. So let's click over here. And if we scroll down a little bit, we're going to see the full set of environment variables that got assigned to the project. So there are a bunch of variables there, but the one that we mostly care about right now is the connection string right here. So notice that this is using the correct convention to set a configuration in our API project, a configuration that has to map exactly to connection strings game store, right? So, and if we click over here to see the value, we can see that this is the correct connection string to talk to our PostgreSQL database, including the password, right? And again, we did not have to figure out how to build this. It's just sent over from the AppHost all the way to the API. And because the correct connection string was sent, the API should have been able to start properly. Now, one more thing that we can do is click here where it says view console logs right there. And this is going to give us a view of what's going on behind the scenes with the application, right? This is the same log that you would see normally in your terminal in VS Code in this case. Now it is available over here in the dashboard. We're going to be able to see logs not just for your API, but for any other resource that is actually sending some logs. And here we can see that, well, initially we kind of had a small issue here trying to execute the migration, which is normal the very first time, but then it had no trouble actually going ahead and applying the migration, as you can see over there. What about we take a look at the actual database, right? So let's go back to resources, and actually I have my pgadmin open over here. Let's see if we can just refresh this. There you go. Here's pgadmin, which, like I said, it is already connected to our database. So I'll expand my game store database right here, expand this a little bit. We can go to schemas, we can go to tables, and sure enough, we have our games table, we have our genres table, and even the EF migrations history table. And we can actually right click on genres, and we can click on view, edit data, all rows, and this should be able to show us all of the data that we seed into this genres table when application starts, which is right there as expected. So that is great. The games table is going to be empty for now, but of course we can work on that. So now that the application is running, we can go back to VS Code. Let's collapse the terminal for a moment, and let's go back into our API, games.http file, and let's see if we can actually create a brand new game in our Aspire hosted application. So let's click on our all games endpoint over here. Let's send a request just to confirm that there's no games right now. Effectively, there's nothing in there. And now we can scroll down a little bit into our post request to create our Street Fighter 2 game over here. Let's click on send request. And sure enough, the game was created. It was assigned ID 1, right? And we can now query for that game 1 over here. Yep, it is working. And we can also query for all of our games, which is just that one for now. So the application is working just like before, but now it is powered by .NET Aspire. To understand what resiliency is and why it is important, let's go over a common scenario in a production environment. Our ASP.NET Core application sends a request to our database server to retrieve some data. But unfortunately, all we get back is an error. Even if you did everything right in your application, you will have to deal with things like network hiccups, short-lived connection drops that are common in the cloud, planned maintenance events caused by cloud providers when they patch or upgrade the servers, and throttling, which happens when you hit resource limits and the database rejects your connections until the load drops. Since all these issues and many others common in the cloud are just temporal, you don't want your application to fail immediately. Instead, you can use a retry strategy where you initially wait some time and then retry the operation. If that fails again, you wait perhaps a little bit more and then try the operation again. And you can keep going with an increasing amount of delay to not overwhelm the database until you exhaust the amount of retries, or hopefully the issues resolve and you get a successful response. This is resiliency, the ability of your system to react to failure and still remain functional, and it extends beyond preventing failures to include recovering and going back to a healthy state. Let's see how .NET Aspire can help with this. The .NET Aspire dashboard gives us the ability to start or stop resources on demand, which can get very handy during local development. Now let's use this feature to temporarily stop our Postgres database to see how our Game Store API reacts to that situation. So what we're going to do here in the dashboard is just click on the stop button right there. So let's click on stop. That's going to go ahead and stop the Postgres container. And now what we want to do is, well, query our API endpoints and see what happens. So let's go back to VS Code over here. And I'm going to try to get the full list of games, right, with this request over here. So click there. And if you go back into the dashboard, I mean, we can see that there's nothing coming back over here, but let's go back to the dashboard to take a quick look at what's going on behind the scenes. So let's click on console logs right here, console logs for the API. And we can see that the API is not just failing, it is actually getting retried. And we can see that over here, right? The operation will be retried after 0 milliseconds, it says, right? So we can see the error there, but the application doesn't just error out, it will get retried. And after a while, we see another error over here, right? It says that, well, the operation will be retried after 1086 milliseconds, right? So this time it is waiting a little bit more, 1 second. And then if we keep going down, we will be able to see another retry over here, right? After 3 seconds, okay? So it keeps retrying automatically until eventually it just gives up or the database goes back to a healthy state, right? So this means that the client integration for PostgreSQL that we enable for our application is automatically wired up for resiliency. And this is the case for all of these client integrations. So by using them, you get resiliency by default, right? If you go back to VS Code, we're going to see that we still don't get any response because it keeps retrying. But now let's go back to the resources and let's see if we can restart the database right now. Okay, restart it. And then let's go back to VS Code. And as you can see, we finally got our response, right? We got a 200 OK. Here is the actual gain that we created a moment ago. And we never saw an error in the application, right? And that is because of the default retry strategy that has been enabled for the PostgreSQL integration, client integration for .NET Aspire. We can see the logs. The last thing that we're going to see is, well, the last stack trace that came from the last retry. Last time it was going to wait for 15 seconds over here. And in the case of MPG SQL, I think it's going to be 6 retries with an increasing amount of time until it eventually gives up, right? But this is resiliency in action. And just by using that client integration, you are already prepared for this kind of situation when you deploy this application to the cloud. To understand what health checks are and why they are important, let's start with a basic question. How can you tell if your backend application is alive? Can it respond to your clients? Here we have our ASP.NET Core API currently running as a container in the cloud. This API is designed to serve multiple clients. Both desktop and mobile devices are sending requests to it. However, at some point, there could be an increasing load on our system with many more clients accessing our API simultaneously. Our container can handle only so many requests at a time. And given the limited available resources, it could eventually run into issues like thread pool starvation, deadlocks, or even connection pool exhaustion, which might turn the container unresponsive. At this point, most client connections will break and will end up with many angry customers. This is where health checks become crucial. We can stand up a special endpoint in our application that can be invoked by a container orchestrator like Kubernetes or Azure Container Apps. When the orchestrator fails to receive a healthy response within the configured timeout period, it understands that there's an issue with the container and then proactively spins up a new container for our application. Again, the orchestrator waits for a healthy response from the container's liveness endpoint, and once it confirms that the new container is healthy, it stops routing traffic to the unhealthy container and redirects clients to the new one. Clients can now start getting successful responses while the orchestrator restarts the unhealthy container to get it back to good shape. This automatic recovery process ensures your application maintains high availability even when individual containers encounter problems. But even if your application is alive, it may not be ready to receive traffic. Imagine a situation where our database is temporarily unavailable, as it's not uncommon in a cloud environment. Our API is alive, but if we let our clients talk to it at that point, they will likely get a bad user experience. To prevent this, our API can expose a readiness endpoint that our orchestrator can invoke to confirm the status of not just our application, but all of its dependencies. The endpoint will likely return an unhealthy status while the database issue persists. But once the problem is resolved, the same endpoint will now return a healthy status. This is the signal for the orchestrator to light up our application and allow it to start receiving traffic from our clients. So, health checks are a monitoring mechanism that verifies if an application is working properly, and they are meant to influence the decisions made by container orchestrators, load balancers, API gateways, and other management services. Let's now explore the health check capabilities of .NET Aspire. Back in our Aspire dashboard, let's once again stop our Postgres database to understand the importance of health checks. So if you go back here and just click on the stop button, of course, that's going to stop the database. But the important thing is to notice that our game store API is still lighting up with a running state. And that means that the API has no idea that one of its critical dependencies is completely down, right? And this is not an issue just during local development, but it will propagate into the cloud if we don't add the proper health checks. So let's see how to fix this. Let's go back into VS Code, and I'm going to stop my AppHost now. Going back to our Explorer view, let's collapse Explorer view and let's actually go into our Solution Explorer, because what we're going to do now is to add a brand new project. So let's right click, in this case on Game Store, New Project, and let's select .NET Aspire Service Defaults. Let's click there. Let's give it a good name, Install.Service Defaults, default directory, and let's click on Create Project. Now let's collapse the Solution Explorer and let's expand our File Explorer to take a look at Service Defaults. Now this Service Default project is nothing more than a class library, but it includes a very important extensions.cs file on the left side, as you can see there, that has smart defaults for resiliency, health checks, telemetry, and even for service discovery. So let's take a quick look at this file. So extensions.cs, let's collapse this. And what we're going to find is that this file is a static class, extensions class, that first it defines the endpoints that are going to be used for the health checks. And then we have this add service defaults method over here, which is really a wrapper around a bunch of other very important methods here. For instance, we have a method that configures OpenTelemetry, which we're going to be covering later in the video. We have a method to configure the default health checks. We configure service discovery, which is going to be useful if your project needs to talk to other projects in the same .NET Aspire application. We also have configurations here, both for service discovery and also for resilience in the case that your application needs to make HTTP client calls into any external service. And then what we're going to focus on right now is actually the piece for health checks. So let's go into add default health checks. I'm going to do F12. Here you're going to find that what this method does is it really just uses the health checks middleware from ASP.NET Core, and it adds a specific check that it calls the self check that immediately just returns a healthy status. And it's also tagged with live, right? So this is going to allow us to confirm if our application is well alive. But one important thing here that is not obvious is that by adding the health checks middleware here, and by using the client integrations of .NET Aspire, we're also incorporating all of the health checks that have been enabled for all of the client integrations for all of these other services, like PostgreSQL in our case. So when we evaluate the health checks for the application, we're also evaluating the health of any of the dependencies. Now, there's one more public method here. It's called map default endpoints. And this is the endpoint that, at least for local development, as you can see over here, it mapped the two endpoints that we saw at the very top, so that the health path /health is going to be used as our readiness endpoint, and our alive path is going to be used as our liveness endpoint. Notice that it filters by the live tag. So for most .NET Aspire applications, really all you want to do is make sure that you invoke map default endpoints and also your add service default endpoints, so that you acquire all of these smart defaults without thinking too much. So to do that, let's start by going into our Solution Explorer. And let's make sure we make a reference from the API project reference and into GameStore.Service Defaults. And after doing that, let's go into our API project, program CS, and I like to add this just after creating my builder. Very first line here is going to be builder.add service defaults, okay, which is coming from the service defaults project. And then let's go down here, and before mapping any other endpoint, we're going to map default endpoints. So this should immediately light up those two alive and health endpoints for our API, and also keep track of the health of the dependencies. But in the case of .NET Aspire, we also need to do one more thing. So let's go back into our AppHost now. Okay, install AppHost, apphost.cs. And one thing that we should do is to let our application model understand that there is a health check for our API project. And to do that, all you have to do is for your add project call, you can make a chained call here too with HTTP health check. Okay, and here is where we're going to introduce the path that has been defined, in this case, for the readiness endpoint, so that the app host can know if the application is ready to go. What is that endpoint? So let's go back into service defaults, extensions, and we will remember that the endpoint is just called /health. Let's copy that, /health, back to app host, and we will put it right here. And in addition, since we don't want our API to successfully start unless our database is ready to go, we can also chain a call here to .wait for database. So this call tells the app host that, hey, do not let my API start unless you can confirm that the database resource has started. And if it has any health checks by itself, make sure that those health checks are, well, healthy before letting the API start. Let's see how this works. So let's go back into our terminal. Let's do Aspire run. And let's start by testing our brand new endpoints, right? So let's collapse this for a moment. Let's go back into our API games.http file. And here I'm going to go ahead and just grab this over there. I'm going to go all the way to the end. And I'm going to add just one more call here to get a response from our alive endpoint. So let's hit send request. And as expected, we are getting a 200 OK response, and it says that it is healthy. So in fact, the application is alive. That's good. But we can also add one more call here for our health endpoint, right? So let's query health. And once again, it comes back with a healthy response. Great. But now let's see what happens if, well, one of the dependencies is not in good shape. So back to the dashboard where everything is running right now. Let's temporarily stop our Postgres database, right? So let's stop this, okay? So database completely stopped. Now let's go back to VS Code. And even if the alive endpoint is going to be just healthy, as you can see, it keeps reporting healthy, no problem. If we query our health endpoint, so let's send a request, it is actually going to take a little bit because the timeout configured for PostgreSQL by default is a little bit long, but eventually it should come back saying, hey, I cannot reach to one of your dependencies, PostgreSQL, so I'm going to come back with an unhealthy response. As you can see right here, it's returning a 503 and it is unhealthy. This is super useful because it immediately can tell any orchestrator, either locally or in the cloud, that there is a problem with a dependency, right? And in fact, if we go back to the Aspire dashboard, we will be able to see that this situation is immediately revealed in the dashboard. Notice this. Right there, our API is reporting an unhealthy status. In fact, we can also click there and we can scroll down here. There's going to be a health checks section over here. Notice that. Here is our endpoint, and we can see that it has an unhealthy status. Now, if we come back and restart the failed dependency, right? Postgres, let's go ahead and restart it. Okay, it comes back to live. Great. So notice that our local orchestrator, the app host, immediately notices that the dependency is back and it goes back to a running and healthy status, which we can confirm right here. Great. So health checks may not be critical during local development, but as soon as you hit the cloud, you will want to have your health checks properly configured. And .NET Aspire greatly helps you by having these smart defaults of having a health check, and also helps you see clearly in the dashboard what could happen if one of those dependencies is down. What is observability? Well, imagine you have deployed your application to your production environment, but eventually the inevitable happens. Your customers start reporting issues, and you suspect that something really bad is impacting your application. So, of course, you start asking questions to figure out what's going on. How is the application performing currently? How to tell exactly what happened? And across all our services and dependencies, where is the bottleneck? Unfortunately, if your application is a black box, you are blind and you will have no idea where to even start troubleshooting. Instead of a black box, what you want to have is a great level of transparency in your application, so you can easily understand what's going on at any given time. You can do this by enabling metrics that tell you how your application is performing, logs that tell you exactly what happened and what led to the issue, and traces that help you find bottlenecks across the system, as well as identify faulty dependencies. These three elements are the pillars of observability, which is the ability to measure and understand the internal state of a system based solely on its external outputs. The best way to enable all the observability pillars for your applications is by using OpenTelemetry, which is an observability framework and toolkit designed to facilitate the generation, export, and collection of telemetry data. OpenTelemetry provides language-specific SDKs to enrich your application code with signals such as logs, traces, and metrics. It also facilitates exporting all this telemetry data to data stores and visualization tools like the .NET Aspire dashboard. This is possible thanks to the OpenTelemetry Protocol, or OTLP, which is a standardized approach for transmitting telemetry data through REST or gRPC. And thanks to this protocol, it is trivial to later add support for other data stores and visualization tools like Azure Application Insights. Now let's see how .NET Aspire adds observability via OpenTelemetry into your applications. The Service Defaults project is already pre-wired for integration with OpenTelemetry. If we go once again into our extensions.cs file and we scroll down a little bit, we are going to find this call to configure OpenTelemetry. And if we jump over there, let's do F12. We're going to see how is that we are configuring OpenTelemetry for our application. Now I'll go back into this call over here in a moment, but down here, we're going to see that the first thing that we do is that we make a call to add OpenTelemetry, which is going to add the essential services for OpenTelemetry, and that allows us to start adding different types of telemetry to the application. For instance, here we are adding services for metrics. So what this is going to do is to add instrumentation so that as our application is executing, we keep track of the different metrics that have been defined for the application. Now, this could be custom metrics or they could be built-in metrics for ASP.NET Core, for any HTTP client calls, and even for the runtime. As you can see, we're using a bunch of default metrics here, which are actually powered by the OpenTelemetry NuGet packages. If we go back into GameStore.ServiceDefault.cs proc, we're going to see that this project already includes a bunch of instrumentation NuGet packages provided by OpenTelemetry, as well as the exporter for the OpenTelemetry protocol. That is what enables these default calls that we have here. And you could have other metrics added here if you needed to, and those will be available for all of the projects that make use of your Service Defaults project. Just like with metrics, we also have this call here to add tracing. So this adds distributed tracing to your application so that you can tell how one call is related to another call or another event across your distributed application, which may consist of multiple services, including your own applications or your own services and any external services. Here you can see that we add one source here for our application or specific application, so we know which events belong to our application or which traces belong to our application. But we also have instrumentation for ASP.NET Core and also instrumentation for HTTP client, so that we can correlate these events across the different parts of the application. We also have, as you saw at the start, this other call at OpenTelemetry on, in this case, on the iLogin builder over here, which is used to also correlate all of your structured logs with the traces that are emitted over here via this instrumentation. Okay. Now, if you go all the way to the end, we're going to see that we also make a call to add OpenTelemetry exporters. Let's go over there quickly. The exporter, what it's going to do to first check if we have enabled this OTel exporter OTLP endpoint environment variable, which is actually going to be set automatically by the app host, and it's going to point to an endpoint in the dashboard that is ready to collect all of this information that we are instrumenting across the application, right? So that's automatic. So this should be true, at least during local development, right? And if it is true, then as you can see here, we add the standard OTLP exporter provided by OpenTelemetry, which knows how to export all of this telemetry data via a very standard protocol, OTLP, that not just the Aspire dashboard, but any other telemetry tool or visualization tool will be able to use. As you can see down here, it is currently commented out by default, but if you wanted to, you can just uncomment this and start sending that same telemetry into places like the Azure Monitor, which shows up in the Azure Application Insights. Now, to see this telemetry in action, what I want to do is to add just one more element into our API so that we get meaningful traces in the Aspire dashboard and you get a better idea of what you're going to use those traces for. So for that, what I have done is I went and pulled up the page for the Aspire Redis integration in the Aspire documentation. And we're going to start by installing the hosting integration so that we can integrate Redis into the app. So let me copy this. Let's go back to VS Code. Going to close this, open the terminal. Let's go into Game Store AppHost. And here is where we're going to install this hosting integration. After doing this, what we can do is go into our apphost.cs file. Let's close this. And perhaps just after defining our database, we can now define one more resource, which is going to be, let's call it Redis. And we'll do builder.add-redis. Let's give it a unique name. And just by doing that, the model now understands that we need a Redis container as part of our application from here on. Of course, we want to establish the relationship between that resource and our API. So let's go ahead and include a call here too with reference. And why not? Let's also make sure we wait for that Redis container to be ready before we consider our API ready. So that takes care of the hosting part, right? So that will make sure that all of the required external services are in place. But we also need to modify our API so that we actually take advantage of that Redis. So let's go back into this page and let's jump into the client integration section here, where we're going to see what is the client integration package that we need to use. So let's just hit copy here, back to VS Code. Let's now go, let's go into the terminal, maximize this, and let's switch into our Game Store API directory. Here is where we're going to install that client integration for Redis. Great. Now let's go into our API project, program CS. And the first thing to do is to add the Redis services that we want to use later on in one of our endpoints. So let's do that over here. Before we build our app, we're going to do builder.add-redis distributed cache. And once again, let's be very careful about the name that we specify here, because once again, it has to match exactly the name that we specified over here in the app host. Remember that we said that this is going to be named Redis. Well, that is going to be used as the environment variable key for the connection string that we'll be using on the API project. So we must use that same name over here. That establishes the connection between the two sides. So now we're ready to start using Redis here. Where are we going to use it? So let's go into our endpoints. Let's go into games endpoints. And this is just one extensions class that defines a bunch of endpoints for the application. In this case, we're going to be focusing in this one endpoint here. That is the one that you can use to retrieve one specific game from the database. Now, what we want to do is to improve this endpoint a little bit so that instead of retrieving the game every time from the database, we will add it to a cache, a Redis cache. And if we find it there, we will first retrieve it from the cache. And only when the cache does not have the game, either because it is the first time or because the cache expired, then we will go back to the database. But otherwise, we will rely only on the cache to release the load from the database. First thing to do here is to introduce a couple of other parameters here to the endpoint. So let's add here our iDistributed cache. Let's just name it cache. And let's also introduce a logger so that we can log at least one line when we have a cache miss. So logger, in this case, let's make it off program logger. And then we're going to expand things a little bit here so that we can start working with the cache. Now, this video is not really about adding caching, but about observability with .NET Aspire. So I'm going to be pasting a few lines over here to speed up the process a little bit. So here I'm going to add the following here, and let me add control dot using system.text.json. Let's see what's going on here. So what we're going to do is to use the cache first to try to get an entry that has a key of the game ID, right? So game ID, the one passed as a parameter, and we're going to be retrieving it as a JSON object on the left side, and we're going to check if it is not null. If it is not null, it means that we have the element in the cache. So we're going to just go ahead and deserialize that cache entry as a game details DTO. This is the DTO that we are ready to return back to the client, and that is going to be our response. That's it. No need to talk to the database in that case. However, if cache JSON is null, then it means that we do need to go into the database and we have a cache miss. So let's start by adding a login entry here that's going to say, well, we got a cache miss for that game with such game ID. And notice that I'm using structured logging here by having here kind of a placeholder for the game ID and specifying the ID on the right side. That is going to help us with the way that we present this log in the Aspire dashboard. And then we're going to modify this last line over here so that we actually store the game in the cache before returning it to the client. So I'm going to remove this last line here. I'm going to paste the following. Okay, let's see what changes we made here. So first we're going to see, well, can we actually find the game in the database? If we can't, it's just a not found, right? So we return it. Otherwise, we turn this game entity or game model into a data transfer object that is ready for returning. But before that, we will go ahead and invoke the setStringAsync method on the cache with the key of game : and the ID of the game. The value is going to be the serialized version of that DTO. And then we're going to be setting an expiration time of 5 minutes. In production, you probably want to have a longer expiration time here, but for our purposes, 5 minutes should be good enough. Finally, we will go ahead and just return that DTO to the client. Lastly, one thing that I like to do is to modify a little bit the login sent by this Redis client so that it is not too verbose, right? It can add a lot of noise in the logs. So here in my Observability.json, I'm just going to add this one entry here so that the Stack Exchange, Redis, and connection multiplexer only shows warning as opposed to every single informational message. Great. So with that in place, let's just close all of this. Let's go back to our terminal and let's do Aspire run. Great. Let's see our dashboard over here. Here's the dashboard, and we can see that Redis is right here, right? It is up and running, ready to go. Our API is already able to talk to Redis. That's why everything is running. So we are really good to go. So let's see what happens when we try to query for one of our games. So back in VS Code, let's collapse this and let's go back into games.http. Let's go up. Let's query this game number 1 that we have created so far. Let's send a request to query for the game. So sure enough, we have retrieved that game here, Trick Fighter 2. But now let's take a look at the Aspire dashboard to see how this shows in our telemetry. We can start by going to the console logs of the API, and sure enough, we are able to see that we were able to log that cache miss for, in this case, for game number 1, which is great. But one thing that you should notice now is that we not just have these console logs available here, but we have a nicer way to take a look at the logs, which is the structured logging. So if you go on the left side into structured, you're going to see that we have all of our entries, but now in a structured logging format. What does that mean? Well, it means that you can actually start filtering and searching for specific elements on your logs. So for instance, I can click in the cache miss at the very end over here, right there. And you will be able to see that we are capturing not just the standard variables for this log entry, but we even have our own keys reflected here. For instance, here is our game ID 1. Okay, so this means that we could, for instance, come into the filters section here, and we could choose a parameter here. The parameter is going to show now here as the game ID. We could say contains 1, it actually shows up here. We can apply the filter, and now this automatically filtered all of those logs to just show us entries that include game 1, right? I can go back here and I can remove all, and then the logs are back. Of course, in this example, it is a little bit trivial, not that interesting, but imagine a case where you have hundreds or thousands of entries here, and you need to start digging into what's going on here by looking at some specific key data that otherwise it is hard to find. This is the advantage of structured logging. But we have more than that, right? So if you see over here, I mentioned that because of OpenTelemetry, we are going to be able to relate our logs to our traces. And in fact, this is a trace that reflects that call that we made a moment ago. So if we click on that trace call over there, what we're going to find is what we know as the distributed trace provided by OpenTelemetry that tells us the entire story of that HTTP GET call from the moment that it arrived to our application all the way down to all of the dependencies. And if we can collapse this a little bit, we can see, well, to start with, we can see how much time this took, right? So we can see the entire time of the whole call. We can see one by one each of the components, including the Redis client and the database, how much each piece involved in this call took. And it is a great way, well, to find bottlenecks across the application or find the pieces that may start causing issues. And you can see here, we can see that initially the call arrived into the API. Then we tried to see if we were able to, well, retrieve that entry from the Redis cache. Of course, we were not able to do it because it was the very first time. So we had to go into the database to store it there and only then return the game back to the client. Now, of course, it is interesting to see what happens the second time, right? So let's go back into traces over here. And besides all of these pings, what we can do is, well, make another call and see how things change, right? You can see that right now it involved 3 components, right? Our API, Redis, and the database. Now let's go back to VS Code and let's try to make another call over here. I'll send another request. It returns to 100 OK. And let's see now how it looks like in the traces. So at this point, I think at least 5 minutes occurred since the last one. And that would be why we still see our database involved in that new call. So let's take a quick look at the logs once again. As you can see, we did get another cache miss, so that's okay. But if we make another call just right now, so let's make another call there, and we go back to traces, we will be able to see that this call did not involve the database at all. And that is because the entry was cached, right? So we can go there and we're going to see that the only participants in this call were our API and the Redis cache. So this is the benefit of having OpenTelemetry traces enabled. You can clearly tell which are the actors in each of these calls, and you can point out where are the bottlenecks and where are the potential issues with dependencies. One more thing that we can explore here is the metrics, right? So we can go over here into metrics, and what we're going to find is that there are a bunch of metrics enabled by all of those NuGet packages that were incorporated into Service Default via OpenTelemetry. So you can see that we have metrics grouped by different areas. Like for instance, we have ASP.NET Core hosting, we have ASP.NET Core routing, we have Kestrel, and we have a bunch of elements here, including the MPG SQL client here, right? We can see metrics related to MPG SQL, the HTTP client, and a bunch of other things available by default. You can always add your own metrics over here if you want to. But for now, for instance, we can take a quick look at HTTP server request duration over here, which is going to give us a nice graph of the duration of this request that we've been sending into our application, at least in this case for the last 5 minutes. Let's see if we can see more here. You can see that the very first request, I think it took way more time than the others, as expected, but then it standardized it into a much lower time. You can do things with these graphs, like for instance, you can show the count if you want to see the cumulative count of requests, like for your application, right? And then there are many other things that you can see. For instance, in the case of MPG SQL, you can look at commands duration. If you're concerned about the database, you can look, let's not show count, but let's show normal counts here. You can see how much time, the calls to a database are taking. And of course, besides this, there's many other things that you can see there. From my perspective, the biggest benefit that you get by adding .NET Aspire into your codebase is the great onboarding experience that it enables. And to show you how this looks like, what I did is that I pushed everything that we worked with across this video into this remote GitHub repository. And I'm going to go ahead and just clone it into my box. I will open it in VS Code, and we'll see if the entire application can just work without any additional configuration. So I'll start by clicking the code button here to copy the URL to the remote repo. And then I'll go back into my terminal here. What I'm going to do, hit clone, paste the URL. I'll name this one Game Store 01. I'll hit enter. Great, so I have my clone now. I'm going to clean this. I'll go into Game Store 01, and then I'll open this in Visual Studio Code. Here we are. I'm going to close a few of these screens. And what I can do now is either hit F5 or we can just do Aspire run as we have done across this video. So let's hit enter. Okay, the AppHost has started, and then we have our dashboard URL, which we can click now. As you can see, the dashboard is back exactly as we had it before. The containers should be showing up in Docker Desktop now. So let's look at, here's the images, here's the containers as expected, and everything is working as we had it before without having to configure anything extra here. And if we wanted to confirm if the API is actually working, well, we can always go back into our games.http file over here. We can confirm that this database is empty to start with the first request. We can go ahead and create a brand new game over here. Let's pause this with this game. And then we can query for all the games over there. We can query for a specific game over here. And we can confirm that all of those traces are available here as they were available before. There's a lot more that .NET Aspire can do to streamline your development process, including plugging in identity providers like Keycloak and EnterID, integrating Azure services like Managed PostgreSQL, Blob Storage, and Key Vault, working with multiple front-end stacks like React and Blazor, and deploying everything to the cloud via services like Azure Container Apps with fine-tuned customizations via Bicep. I covered all of that and a whole lot more in the .NET Cloud Developer Bootcamp, a complete step-by-step blueprint for C# developers who want to build production-ready .NET applications for the Azure cloud at scale. You can check out all the details at netacademy.io/bootcamp. Thanks for watching, and I'll see you in the next one.